All right, so we're going to do a few more examples with elimination, and we're going to talk about um, just kind of some basic procedural going through that flow map situation again. So when I'm looking at this example, I can see that they're both in standard form. So we are definitely going to be using elimination for this problem because remember, standard form is going to be ax squared, excuse me, not ax squared, ax plus by equals c. And elimination is always best when it's in standard form. So you're going to look at your pieces and you're going to look and see how they line up. So if I have my x's and then I have my y's. So when I'm looking at those two, I need to first look at my coefficients. Remember, the coefficient is the number that's in front. So that would be your a or your b value. And when I'm looking at those, I need to decide, first of all, are they the same? And if they're not the same, which one can I easily turn into the other? So when I look at my x's, I have 8 and I have 6. So 8 and 6, we can turn 8 and 6 into each other, but we'd have to multiply both of them. And so that would essentially be more work. It's not impossible, but let's check the y's out. So when I look at my y's, I have 14 and I have 7. So 14 and 7 are going to be much easier to take 7 and turn that into 14. So how would we turn 7 into 14? So to turn 7 into 14, we would take the entire second equation and we would multiply that equation by 2. Again, we're multiplying it by 2 because we want to turn 7 into 14. So once we do that, the top equation is not going to change. So that's going to stay the same. But we're going to distribute here. So we're going to multiply. So we have the 2 times the negative 6. That's going to give me negative 12x. Then we have 2 times the negative 7. So that's going to be minus 14y. And then the 2 times the negative 10. So that's going to be minus 20. Now, at this point, we want to eliminate, which is the reason it's called elimination, the y values because my y values have that same coefficient. Okay, so the question is do I need to add or subtract? Okay, so add or subtract. So if I add 14 plus negative 14, that's going to give me 0. If I subtract 14 minus negative 14, that's going to give me 28. And we don't want to get 28. We want to eliminate. So in this situation, we are definitely going to add because we want to make it eliminate and equal 0. So right here, we're going to add this example, and we're going to add each column. So 8 plus negative 12 is going to give me negative 4x. 14 plus negative 14, that's going to eliminate, that's 0, equals 4 plus negative 20, which is going to be negative 16. All right, so at this point I can now solve for x. Okay, so we've eliminated the y, and the reason we eliminated for y is because we wanted to get y by itself, or excuse me, x by itself. So now to solve for x, we're going to divide by negative 4, and x is now going to equal positive 4. So we have that x value, which is half of the answer, because remember our final answer needs to be an actual point. So our solution needs to be an xy point. So when we're done, our solution for this particular problem, we've started out with 4, now we need to find the y. So how are we going to find the y? So now we're going to substitute x back into our problem. Okay, so x equals 4. All right, so it doesn't matter which problem or which equation you substitute back in for, because you will essentially get the same y value, which is the reason it's a system, because they should have the same x and the same y. So I'm going to substitute it back into the first one. And I'm going to do 8. And where x is, I'm going to put a placeholder, because we have x equals 4 plus 14y equals 4. And in that placeholder, I'm going to put in 4. And so 8 times 4 is going to give me 32 plus 14 equals 4. And we're going to solve this equation. And we're going to solve this equation for y. Okay? So I'm going to subtract 32. So 14y is now going to equal negative 28. Divide by 14. And y equals negative 2. So my solution for this problem is 4, negative 2. Okay. All right, so one more example. So this problem, I'm going to look at my x's and I'm going to look at my y's. So here's my x's, here's my y's. Now with my x's and y's, my 3, I can't turn the 3 into a 5 or 5 into a 3, and I can't turn the 2 into a 5 or 5 into a 2. So we're actually going to have to multiply twice here. So whichever variable you pick, either one will work. You just got to make sure you follow the mathematical process correctly. Either one you pick will essentially work. So I'm actually going to pick my x's is the one that I'm going to lead with here. So this is the one that I'm going to do. So in order to set that up, I need to take my bottom equation and multiply it by 3 because the other one had 3x. And I'm going to take my top equation and multiply it by 5. And the reason I want to do that is because 3 and 5, the least common number that I can make from both of those is 15. So if I have 3, I'll multiply it by 5. If I have 5, I'll multiply it by 3. So when I simplify this, I get 15x minus 10y, because I'm going to distribute and multiply the whole thing, times 10. So we're going to multiply here. We're going to do it for the second equation. So 3 times 5 is going to give me 15. 3 times negative 5y is going to give me negative 15y, and that's going to equal 30. All right, so again, we decided to eliminate x's, so we've got to make the decision. Do we need to add or subtract? Okay, so we want to make sure we eliminate that x variable because that's the one we chose. So if I add 15 and 15, that's going to give me 30, which is not going to eliminate. If I subtract 15 minus 15, that's going to give me 0. So I definitely am going to want to subtract here so that I get that elimination. So I'm going to highlight the whole bottom equation, and I'm going to subtract that. So column 1, 15 minus 15, that equals 0. So we're going to cancel that out. So then we have negative 10 minus negative 15. So that's going to give me positive 5y. 10 minus 30 is going to give me negative 20. Divide by 5. And y equals negative 4. So again, we're starting with our solution here. Remember, we're going to have to find both of them. But we have the y value this time, so this is going to be negative 4. All right, and you can pick any of the original equations to plug it back into. Again, it really doesn't matter. And I'm going to pick the first one. So I have 3x, excuse me, that should be minus 2y, but instead of y, I'm going to put a placeholder equals 2. And in that placeholder, I'm going to put in negative 4. So we're going to do 3x, negative 2 times negative 4 is going to give me plus 8 equals 2. So then we're going to solve for x now. All right, so I have 3x. We're going to subtract that 8. And in subtracting 8, that's going to give me negative 6. Divide by 3. And x equals negative 2.